Now we have to start our next chapter, which is limit. So you have studied much more things about the limit, various properties. You have handled much more of functions to find out their limits, right? So now we are going to see what the definition or the basic concept of this limit. So before going to the limit, we should know what a function means. So let us recall or revise some part of this function. So before starting limit, we discuss about function. So you also have studied this concept of function in your 11th and 12th class. So let me recall this thing, function. So what mean by a function? So the definition of a function is a function f from x to y so it is a function f from x to y is a rule that assigns a unique element y in y to each element x in x. So you might have seen, read or write exactly the same definition in your 11th and 12th class. So a function f from x to y is a rule that assigns a unique element y in y to each element x in x. It means function is a rule between two sets x and y. So to which rule we can say that it is a function? So suppose I have a set x with some elements, I have a set y with some elements, and I define some rule f between the two sets. So which rule can be a function? Which rule that is defined from set x to set y can be a function? So this definition says that if x has elements, y has some elements, then a rule we are defining between this set x and y. A function is what? Function is a rule that assigns unique element y for each element x in x. Right? And in this case we say that image of y is image of x. Right? So under this rule, is it possible that can we call it as a function? So it is just a mapping from set x to set y. So it is your job to take two sets x and y with some possibility. If this have one element, this have one element, and I define a map like this, is it a function? Yes, definitely it is a function. It is a rule under which every element we have assigned every element of y to each element x in x. That means this element is unique image of this element in x, right? So if I consider two elements in set x, now is it a function? Yes, definitely it is a function. If I map this to this, is it possible? Is it a function? Yes, it is a function, because for this element we have assigned, for this unique element we have assigned this element in x. Right? A rule that assigns unique element to each element. That means we have assigned this unique element to this element. We have assigned this unique element to this element in X. So is it possible if this has one element and Y has two elements and I have map like this? So it is a function, it is a function. Whether it is a function, so the definition says that if we assign a unique element to each element in X, and this is not the case, we have assigned two elements from Y to this element, to this single element. So it is not possible, it is not a function. So it is not possible in this world that the square of 2 we have taken in our college is 4, and somewhere in Pune it is 9, somewhere in Bangalore it is 10, something different. Is it possible? No, the square of 2 is definitely 4. Wherever and whoever calculate it, it doesn't matter, right? So it is a function. So my question is, it is question for you, how many functions can be defined on X and Y with, if set X has 2 element, set Y has 3 element. If set X has 2 elements, set Y has 2 elements. If set X has 3 element, set Y has 2 elements. So it is your job to play with this game. Take 2 elements from in this set, take 2 elements in this set and try to map how many maps we can get, right? And then if f from X to Y is a function, then we write for y in Y that y is equal to f of x for x in X. It means that x is element from the input set, y is element from the output set, and y is image of x under this function f, right? So this is set of input and this is set of output, simply speaking. So x is independent variable, x is independent variable and y is dependent variable. Why it is so? Because we express y in terms of x. Y is equal to sin x, y equal to cos x, y equal to 1 plus x, y equal to x square, y equal to log x, y equal to e raised to x. So we express y in terms of x. So y depends on x and x is independent, right? So then the next definition is domain. So domain of function, the set x of all possible input values, is called the domain of the function, right? So domain is what? Whatever input you have given to the function f, then it will be the domain. Because if I have a function 1 by x, so for the function 1 by x, I cannot give 0 as input because I cannot find the value of, if I have a function 1 by x. So x equal to 0 cannot be given as input to this function because I don't have the value or output for this fraction 1 upon 0 or quotient 1 upon 0, right? So I cannot give 0 as an input to this function. So 0 will not be there in the domain of this function. Are you getting? Yes. domain of the function. Then codomain is the set that contains the outputs, is the set Y. The set that contains output. And range, the set of all outputs, the set of all outputs or output values of f as x of f for x in x is called the range of the function. So if f is function, then this set is domain, this set is codomain, and subset of codomain, which is collection of all the outputs of function f, is the range of function, right? Now for example, let me explain this domain, codomain and range. Example 1, f is function from set of real numbers to set of roughly speaking, I mentioned the set of output is real number, so sorry, set of input is real number and set of output is a real number, and function is defined as f of x equal to x. So the question is, find the domain and the range of the function. So for this function, which real numbers can be given as input? Any real number, because this is identity function. So for any real number, I am giving the input and I will get output in the end, and the input output is same. I am giving input x and I am getting output x, right? So if I give one as input, I will get 1 as output. I will give 10 as input, I will get 10 as an output, right? So the domain will be the whole set R, which is from minus infinity to plus infinity. The range is, for this function, as I am giving the input, I am getting the same output in the end. So it is also R, from minus infinity to plus infinity. If I take the function f from real numbers to real numbers, it is defined as f of x equal to 1 upon x. So what is the domain and range for this function? Domain, if I give 1 as input, I will get 1 upon 1 output. If I give 2 input, I will get 1 upon 2 as output. If I give 0.05 as input, so I will get 1 upon 0.05 as output. So for every real number, every input, I will get some output, right? And it is unique value. So what happens if I give 0 as an input? For this case only, I am not having any output, right? So domain should be what? R minus single element 0. I should not get any output for the value 0. If I provide 0 as an input, I will not get anything in the output. So you can write it as minus infinity to 0 and 0 to infinity. We have to just reject or minus an element 0. What is the range? We can have any real number, positive, negative and 0. So the range is whole real numbers. Now if I take f set of real numbers to set of real numbers and I define it as square root of x. So what the domain and code range of the function? Domain is for what value of function, for what value of real numbers I am getting output. If I give 0 as an input, I will get square root of 0 is 0. If I give 2 as an input, so I will get square root of 2 as output, right? If I give 100 as an input, I will get square root of 100, which is 10 in the output. If I give square root of minus 1, if I give minus 1 as an input, so whether I am getting square root of minus 1 in the output, because it should be there in the set of output R. But square root of minus 1 is not a real number, square root of minus 2 is not a real number. That means I cannot give negative real number as an input for this function, because I am not getting the value of square root of negative number to be a real number, right? It is not a real number. Square root of negative number is not a real number. So what I should have in the domain? 0, it will work, equal to 0 will work. So any real number greater than 0 will work. So this is the domain of the function. What will be codomain of the, what will be range of the function? What I will get in output. So the positive square root. So in the output, I will get also 0 and the positive real numbers. I will not get negative value as a square root of any real number. Now if I define a function by x square, so what is the domain and range for this function? So which are the real numbers can be given as an input for this function? If I take 0, I will get 0 square. If I take 1, I will get 1 square. If I take minus 5, I will get minus 5 square. Right? So for any real number, either positive or negative, I will get its square, which is again a real number, but it is a positive real number in the output, right? So in the input set, I can give any real number as an input for this function. So the domain is the whole set R. That means all the real numbers from minus infinity to plus infinity. And range, I take any real number. If I take 0, the output will be 0 square, 0. If I take negative real number, the square is positive. So in any case, I am not getting negative output. So what the output or range of the function should be? 0 to infinity. Positive real numbers, non-negative real numbers, including 0, right? So there are many more functions and we have to go to the graph of the function. So graph. And the definition is, if f is a function with domain x, its graph consists of points in the Cartesian plane So it means simply a graph of function f is x comma y such that y is equal to f of x and x is from the set of input. So the graph of function is nothing but the ordered pairs. So if f is function from set x to set y, so graph of f will be subset of the Cartesian product of x cross y. Right? So let me take some examples of graph. So I define f function from R to R, and it is to be easiest function. We have taken f of x equal to x. We know that the domain is R set of real numbers, the range is R set of real numbers, and now we have to draw the graph. So we have to draw the graph. The x-axis, the y-axis, and the 0 should be the identification of the plane coordinate system, right? So try to take some values x and y and try to draw a graph. If I put x equal to 0, I'll get y equal to 0. Y equal to x is the function, right? F of x equal to x or y equal to x is a function. If I take x equal to 1, I will get y equal to 1. If x is 1, so I should have y equal to 1. If I take x equal to 2, I should have y equal to 2. So if x equal to 2, I should have y equal to 2. If I take x equal to 3, I should have y equal to 3 because y equal to x. So if I take x equal to minus 1, I should have y equal to minus 1. If I take, it is minus 1, minus 1. If I take x equal to minus 2, I should have y equal to minus 2. So it is minus 2, minus 2. If I take x equal to minus 3, I should have y equal to minus 3. So it is minus 3, it is minus 3. So this is the graph of the function y equal to x. And the graph of function is this coordinates or collection of order pairs with the values of x and y is the definition of graph of function. Right? The next function the second function f from set of real numbers to set of real numbers, and it is defined as f of x equal to x square. Right? We have discussed its domain and range. So what the graph of this function will be? This is x-axis, this is y-axis, this is origin 0, and for different value of x, find out the value of y, which is x square. For x equal to 0, it is 0. For 1, it is 1. For 2, it is 4. For 3, it is 9. For minus 1, it is 1. For minus 2, it is 4. For minus 3, it is 9. So for the value of x and y, we can have this graph, which is graph of y equal to x square. We call it as a parabola, right? So if we have to draw the graph of f from R to R given by f of x equal to minus x, how the graph will be? Exactly same of this graph y equal to x, but with all the values will be negative. All the value will be changed by sign. The positive values becomes negative, negative values becomes positive. So how the graph will become? Try to draw this graph. X-axis, y-axis, origin 0. It was the graph of y equal to x, so it is the graph of y equal to minus x passing through origin. Similarly, if this is the graph of y equal to x square, my question is, what is the graph of f of x equal to minus x square? So if this is the y equal to x square, so y equal to minus x square will be, all the values will get reversed, or right? It means that this above x-axis, your y-axis have positive value. Below x-axis, our y has negative values. So the graph of y equal to minus x square, it means it will reflect along the x-axis or along this positive y-axis. Y is positive. Along below x-axis along negative y-axis y have negative values, so our graph will flipped along x-axis and it is graph of y equal to minus x square. Right? Next example, if I want a graph of x plus 1, what will happen? This is x-axis, this is y-axis. So in this graph of y equal to x, plus 1 will be added everywhere, right? So it is 1, it becomes 2, 2 becomes 3, 3 becomes 4, minus 1 becomes 0, minus 2 becomes minus 1, minus 3 becomes minus 2. So our graph y equal to x will shifted by height 1, right? Initially it was here y equal to x, so it is y equal to x plus 1. It will passing through these points, minus 1 comma 0, and it is 0 comma 1. Right? If I want a graph of f of x equal to x square plus 5, so what this thing will be? Every value of x square will be shifted by plus 5. That means shifted in upward direction by plus 5. So the graph of x square plus 5 will be, this is x-axis, this is y-axis, it is 0. So somewhere here it is 5 on x-axis. So y equal to x square will be shifted here. It is y equal to x square plus 5. If I want to draw a graph of f of x equal to x square minus 10, then what? So this is x-axis, this is y-axis, this is y-axis, this is x-axis, this is origin. It means what? Every value of x square will decrease by minus 10. That means every value will move downward by 10. So my graph y equal to x square will be shifted here, which is minus 10 on the y-axis. So this is the graph of the parabola y equal to x square minus 10. Right? The next thing, if I want to define function f of x to be 6 minus x square. So we have seen the graph of minus of x square, and here we want 6 minus x square. So how the graph will be? This is x-axis, this is origin, this is y-axis. So graph of minus x square, in every value plus 6 will be added, plus 6. So graph will move in upward direction. So if here it is 6, so draw the graph of minus x square at this 6. So this is the graph, the parabola. It is y equal to 6 minus x square, or minus x square plus 6. So these are some combinations of the graph. The next graph, number 9. If I have to draw the graph of f is function from R to R, we have defined it as f of x equal to 1 by x. We have find its domain and range. How the graph of the function will be? X, y, and this is 0. Now observe for this function. If input is positive, the output 1 by x is positive. If input is negative, the output 1 by x will be negative. That means we will have the graph of this function in first quadrant and in third quadrant, right? Because in the second quadrant x is negative and y is positive. In fourth quadrant x is positive and y is negative. It will not be the case for this graph. If x is positive, y is positive, it is in first quadrant. If x is negative, y is negative in the third quadrant, right? And if we increase x in the input, we can have 1 by x, a small number in the output. That means it is reciprocal. We are giving x as an input and we have 1 by x. It's reciprocal in the output. That means if we give a large number in the input, we can have a small number in the output. Conversely, if we give small number in the input, we will have large number in the output. So the graph will be this. And if we give x equal to 1, y will be 1. If we give x equal to minus 1, y will be minus 1. So this is the graph that if x is very small, y is increasing. If x is increasing, y is decreasing. Here also the graph will be like this. So this is the graph of 1 by x. Next example, number 10. We define function f of x to be modulus of x. And what the definition of this function is? F of x equal to modulus of x is plus x if x is greater equal 0, equal to minus x if x is less than 0. So what the graph of the function will be? This is x-axis, this is y-axis, 0. If x is 0 or greater than 0, then graph is y equal to x. So for positive x, the graph of the function is from y equal to x, it is y equal to x. And if x is negative, x less than 0, the graph of function is y equal to minus x. So this is the graph of y equal to mod x. Correct? So if we have to draw the graph of f of x equal to 2 plus mod x, or f of x equal to mod x minus 3. So for 2 plus mod x, our graph will be shifted every value by plus 2. So the graph will move to, this is x-axis, this is y-axis. So the graph of mod x will be shifted to by height 2. So it is the graph of mod x. It is y equal to 2 plus mod x. If mod x minus 3, the every value of the function will be shifted downward by distance 3. So if this is minus 3, the graph of mod of x minus 3 will be this. Sorry, it is wrong. So this is the graph of y equal to mod x minus 3. The next thing is 12. F of x equal to square root of 1 minus x square. So how to draw this graph? Consider y equal to square root of 1 minus x square. By squaring, it is y square equal to 1 minus x square. That means x square plus y square equal to 1. So it is x-axis, y-axis 0. It is circle of radius 1. Right? It is 1 comma 0. It is minus 1 comma 0. It is 0 comma minus 1. It is 0 comma 1. But it is not the graph of the function. The function is what? Positive square root of 1 minus x square. So this is the positive value of the square root. So this is x-axis, this is y-axis 0. So the graph for positive value of y is this part. So this is the graph of y equal to square root 1 minus x square. This is minus 1 comma 0. This is 1 comma 0. This is 0 comma 1. So what will be this part? This is for negative value of y. So this graph will be x-axis, y-axis 0. So this half circle will be y equal to negative square root of 1 minus x square. So this is the graph of the function. So in our next lecture, we will see what is meant by a limit of a function and some of the examples of limit.